Okay, Toby, so it's going to be the final count on the weed patch experiment.
That's it.
And how's it looking so far?
Well, not too bad. Every time a seedling's germinated, I've basically been putting a piece of wire in, just like this one down here.
Right, so you've marked, every day you've been out here and you've marked all the new seedlings that have popped up.
That's it.
And then we can see who's then been destroyed by snails and slugs and everything else and who's survived.
Yeah, well, it was a really nice method that Darwin thought of to try and illustrate the sort of struggle for in nature, really. I mean, we look out over this sort of plot and see a nice, tranquil, harmonic existence.
Yeah.
But there's a lot of death and destruction.
Death and carnage in there, isn't it?
Just how bad was it? Every wire without a plant is a tiny gravestone for a dead seedling. We can now compare the number of survivors with the number of fatalities by counting the wires.
So I had 55 and you had?
90.
That means we've had a total of 454 seedlings have germinated in this patch.
Right.
Through the life of the experiment, so since January. And that's 284 seedlings we've had die in total out of 454.
Right.
That is about a 62% death rate.
So this is why Darwin chose to study seedlings, because that's the most vulnerable part of the plant's life when they face their highest mortality rate.
That's it.
This experiment drives home just how tough it is for seedlings to survive. In our weed patch, well over half the plants never make it.
So simple seedlings, living or dying in a tiny weed plot. Now it took a real genius like Darwin to make a leap to a much bigger picture. Now, he could see across nature it was natural selection that decided who lives or who dies, who are the winners, who are the losers, and it's exactly that which drives the evolution of life on planet Earth.
On his voyage to the Galapagos, Darwin saw that the natural world was often a brutal place. Now it's clear to him that the winners are those individuals who happen to be stronger, cleverer, faster than others in their species. They're the ones most likely to reproduce, and so have offspring similar to themselves. Losers usually fail to reproduce, and so over many generations, the qualities that help survival are emphasized. Qualities that don't help survival disappear. And new species are slowly, relentlessly created. For Darwin, natural selection means the survival of the strongest and fittest. But he's not only talking about the physically fit, but also the best fit to the environment. This is more subtle and more interesting. To investigate this, there's no need for world travel. Darwin just goes around the corner from Down House, and so will I. This is Great Pucklands Meadow. Darwin sees the meadow as a microcosm of nature at large. What looks like a uniform field of grasses actually has many different environments. Everywhere Darwin looks, he finds evidence that species survive and evolve by finding the niches that best suit. Darwin goes on to count exactly how many species he can find in Great Pucklands. For 12 months he crisscrosses the meadow and records everything. It's the first time anyone has done such a detailed survey of plant life. A century and a half later, I've joined staff from the Natural History Museum and others to repeat Darwin's study. But I need to know what to look for.
What do I do? How do you do it?
Observe is the first thing. I think that is the key, is don't just quickly look and think, right, that's all the same. You look at this piece of grassland here and quick look, you probably think, one or two things. There are probably about 20 different species of grass here. This is Coxford, Dactylus glomerata, one of the commonest British plants. Here's another one. That's a different plant. That's false oat grass, another extremely common plant. Let's find another one here. That's Yorkshire fog, another very common. So I've got three just within a hand's reach, and probably if I go a little bit further away, there's another one there. Wavy hair, no, Deschampsia, hairgrass, another one, 4. So you can see very quickly, even though if you don't know the names of these plants, they're different.
You can see just by looking at them, you can see they are completely different.
I never thought I'd be so interested in how many types of grass I can find in a meadow. Darwin reveals that this one meadow is crammed with many different grasses and other types of plant, all jostling for survival. He counts 142 species. We find almost as many, an impressive tally in a single meadow.
Plants, like animals, fill different niches. Certain plants are better at living in slightly wetter conditions, slightly drier conditions. For example, here, the top of this hill here, where we're on Puckland's Meadow, the soil is slightly acidic, so there are plants here that like slightly acidic soil. And as you go over the hill on the edge down there, you go into an area where the soil is chalky. So plants, like us, we tend to sort of fit what's best for us.
Darwin knows that the struggle for existence doesn't just set neighbour against neighbour. He's the first to realise just how intricate the connections between plants, insects and other animals can be. To explain what I mean, I need to go back to my farm. Darwin never did this experiment, but he does describe the thinking behind it. That's enough for me to run it with the help of my mate Dolly.
Through here, Dol. In this wheelbarrow, something slightly unusual. It's some bumblebee nests. And these are for an experiment I'm going to carry out. And it's an experiment that Darwin didn't really have a chance to carry out. So it might be a bit hit and miss. It doesn't just include bumblebees. It's going to be a bit of fun. Through here, Dolly. Okay.
The experiment begins with a surprising suggestion. The number of cats on a farm will affect the amount of red clover in nearby fields. On the surface, cats and flowers look as if they've nothing in common. But delve deeper, as Darwin does, and you begin to see that life connects in curious ways. Cats eat field mice, of course. Less obvious is that field mice can wreck bumblebee nests and eat young bees. So Darwin realises the more cats in an area, the more mice get eaten. And therefore, more bumblebee nests should survive. But that's not all. Red clover can only be pollinated by bumblebees. So, Darwin's prediction, the more cats in an area, the more red clover.